So, anyway. All right, so here we go. Are we a 5-star Uber driver? What are some things that you have to think about as an Uber driver? Things that would...
Clean car.
Okay, clean car. Something else. Gas. Okay, gas is a lot. Safety. Anything else? Your time, how much time you have available. Now, do y'all know anybody that drives Uber? Because my husband did DoorDash for a little while, and then, like, after so many dashes, you have to, like, declare these are the hours I want to work, but he never could do that because it was kind of a fill and miss, so he had to give that up. But I wonder if Uber does the same thing. I don't know. Okay. Yeah. All right, so let's take a look at number 2. So that was just really kind of opinion, things that we thought might be in there. All right, so when you pick up your first group of tourists, your trip odometer reads 0 miles. When you drop them off at the Statue of Liberty 40 minutes later, the odometer reads 17.5 miles. Must there have been a time during the trip when the odometer read exactly 8 miles? Yes or no?
Yes.
Yeah, why?
No, it's because the odometer moves continuously.
Yeah, okay. So the odometer moves continuously. So to go from 0 to 17.5, it had to pass 8. Okay, that makes sense, right? The odometer moves constantly. All right, we don't see it as much as we used to. Any of y'all have an older car where it's still not digital? Yeah, so you can see it move, which is kind of fun. Anyway, okay. I've just now moved up into the world of a digital odometer. It's kind of interesting. All right, anyway. And I sold the van. Did I tell y'all I sold the Swagger wagon? Sold it to my niece so she could haul her babies. Okay. Yeah, the air doesn't work and some other things she's had to get fixed, but it still hauls children. All right, here we go. Question 3. So at 3 p.m., we're hired by a group of art teachers to take them from Long Island to MoMA. What is that? Do y'all know? Museum of Modern Art. And they're 50 miles apart. So we dropped them off at 4 p.m., so it took us an hour. Is it possible that at some point on the trip, I was 53 miles away from the museum? Would that be possible?
Yes.
Okay, why?
Well, if you're talking about, like, straight to it, then you could have, like, went off to go get on the interstate to go there.
Right, so it might be, as the bird flies, it might be 50 miles, but when we talk about the actual roads to get there, it might be more, right? So we live about, on the road, almost 3 miles from my parents. As the bird flies, it's only about a mile, okay? It's just because of the road structure. So road structure, could we have had maybe construction and a detour? I mean, that might happen as well. Especially if you ever use Waze, you've ever been on Waze and all of a sudden it just like, go somewhere else. All right, so it anticipates traffic and things like that. So it might take you more mileage to get there, but less time, all right, to get there. So that is a possibility, okay? We took something that was maybe not a direct route. Okay? Now, the question, must there have been a time when I was 53 miles away? No, okay, because I could have gone straight there, okay? So I didn't have to have, okay, that distance. All right, and then last situation. It says, during your 8-hour shift, you made 12 Uber trips. Your first trip had 2 passengers and your last trip had 4. Should we assume that one of your trips had 3 passengers? No, okay? Why?
Because just because of that 2 and 4 doesn't guarantee the fact that we're safe.
That's right. The number of passengers isn't related to the trip at all, really, okay? So the number of passengers isn't really related to the number of trips. Okay, so there's no guarantee of a specific size. Okay? Well, congratulations. You've just walked through the intermediate value theorem. Okay? What does the word intermediate mean? Middle, in between. All right? It's one way to think about it. So when we think about the intermediate value theorem, okay, we use it to prove that a certain y value, so intermediate value theorem deals with y values. Okay, that's important. We're talking about y values. It's used to guarantee or to prove that a specific or a certain y value, and here's the key word, must exist. Okay, so it's used to prove that a certain y value must exist. Okay, so with all big theorems, there are conditions and conclusions. All right, so just like we talked about the other day, here's the first condition. If a function f of x is continuous. So that's the first thing. All right, we got to have continuity. If we think about the odometer, that's exactly what Caleb said, that the odometer moved continuously, right? It doesn't stop and start. It moves continuously as we're traveling. Okay, so there's our condition. And then our conclusion, this is what we can conclude, all right? Then f of x, so the function, attains, another way to say that would be hits, every y value between f at A and f at B. And I should have put that continuity interval up here as continuous, let's say this, on AB. Okay, so if we're continuous on an interval, then f of x, meaning my y values, we're going to attain every y value between the function value at A and the function value at B. Okay, so the condition, continuity is our only condition. Okay, continuity on an interval. And then if it is continuous, right, that means we got no holes, no jumps, no asymptotes. We're going to hit every y value between those two y values. Okay, that's what it says, and that's all it says. Right? Well, how do we prove it? There are a couple of things that we need to do. All right, first we have to verify continuity. If I'm looking at a graph, no big. If I'm looking at a function itself, we might need to do those two limits and the value of the function, all that good stuff. Then we want to identify those two y values at the beginning and end. So we identify f at A and f at B. And then we check that our desired y value is in that interval. And a lot of this you're going to be able to do without writing anything down. You're going to be able just to look at it, okay, to verify that it's true, which is nice. But those are the three things we should think about. Okay. Now, as with all things free response, you know, we kind of have these sentence stems that we use. We talked about those last year, okay? I want to give you one for your justification stem for this, okay? So this might be your sentence. Since, all right, we'll put a blank there. This is where we would put our function. Is continuous on, and then we would state our interval, okay, so from A to B, and f at A equals whatever it equals, and f at B is whatever it equals. The intermediate value theorem guarantees that f at whatever x value they give me exists. Okay. And that's kind of our proof statement. All right. The things that we will check for to make sure that it's true. Now, one of the things that we do a lot of are sketching graphs based on conditions, okay? And if you looked at any of the practice for 14 and 15, there were some ones where it gave you some limits, it gave you some points, and you had to kind of create a graph. I would definitely look at those. You're going to see that on the quiz tomorrow, okay? So you're going to see one of those, so be sure you've looked at those. So the same thing is kind of true here, all right? It asked me to sketch a graph that would not satisfy the conditions of the intermediate value theorem, okay? What's the condition that we always have to have? What did we just say? What's that one condition it has to always have? It has to be continuous. And so if we want to sketch something where it would not apply, I sketch something that's not continuous. And that's it. Okay, I don't have to do anything super fancy. So if we're talking about a graph that's not continuous, I might just do a jump discontinuity. Okay. That would not satisfy the conditions of the intermediate value theorem. All right. And the reason why is because it is not continuous. Sometimes when they give me questions like this, and we're going to actually do some in a second here from some released exams, they will tell us things about continuity. Now, one thing you don't know yet is about something called differentiability. We'll get there in Unit 2. Okay, in fact, I've already planned that lesson. I'm going to rewrite it a little bit. But first time I did it was with roller coasters, and they have a little bit better way of doing it with the Desmos activity now that I like really well. So I looked at that yesterday. But differentiability implies continuity, okay? So if they ever tell you that something is differentiable, you can assume, you can state that it's continuous, okay? So I don't know if you'll see that today or over the next few days, but I just wanted to be sure you hear those words. You don't understand why yet, but that's what it means, okay? If you see differentiable or whatever, it is continuous, okay? All right, so let's look at this one. So the function h of x is continuous, all right? On a closed interval, well, there we go. Okay, those are the conditions I need for IVT to work, okay? So we know that IVT will work because the only condition is continuity, okay? It tells me that h at -3 is 10 and h of 7 is -2. Is there a guarantee that there's some value a in the domain such that h of a is going to equal 1, okay? And we just justify our answer. The good news is they did all the hard work for me. I don't even have to do any. I don't need to know what f is, all right? Does 1 for a y value fall between 10 and -2? Yes, it does. So this is where we would write our statement. So since h of x is continuous on -3, 7, and h at -3 equals 10, and h at 7 equals -2, the IVT guarantees that a value a in the domain exists where h of a is equal to 1. Okay? Yep, it's a long sentence, but it is what it is. Okay? You could also say all of that, the intermediate value theorem applies. All right, so those are kind of things they're going to ask me in a free response. You will see the big three theorems at some point in a free response question. Okay, this is the first one. All right, the other two are extreme and mean. All right, so we have intermediate, we have extreme, and we have mean. And they are on every exam in a free response question. I've not seen one not be there. Okay, so knowing which one we use and why. Let's do another one, all right, where we have to guarantee or show that it's true, because it asks, does the intermediate value theorem apply? Okay. So let's look at this one. It says, let h be the function defined by h of x equals x cubed minus 2x squared minus 4x minus 5. Okay. Can the IVT be applied to guarantee a value in the interval from 1 to 5 where h of x is equal to 0? Right? So let's talk about what we have to establish. First of all, what's the first thing we got to know? Continuous. Is this function going to be continuous? Yes. Why do we know that? Well, what kind of function is it? It's cubic. It's a polynomial function. All right? So we know it's continuous because all polynomial functions are continuous. Okay? So we know that's true. All right? That's one of those guaranteed things we can use. All right? We know polynomial functions are continuous. What's the next thing I need to check? Okay, so we know it's going to apply because we've got an interval there. Okay. How are we going to know if that function's ever going to equal 0? Yeah, plug in the two values for your interval. So let's do h at 1. So 1 cubed minus 2 times 1 squared minus 4 times 1 minus 5. Let's get a number. Okay, so we do it for the top, all right, or the lower bound, and then we're going to do it for the upper bound. 5 cubed minus 2 times 5 squared minus 4 times 5 minus 5. This one's a little bit trickier. 25 times 5, 125. I did that in my head. That's dangerous. Minus 25 times 2 would be 50, minus 20, minus 5. So 125 minus 75 will be 50. Okay. So my two y values are negative 10 and 50. Is 0 between them? Yep. Okay. So here we go. All right. Can the intermediate value theorem be applied? Well, since h of x is a polynomial, it is continuous on 1, 5. The value of h at 1 is negative 10, and h at 5 is 50. Therefore, the IVT applies, and h of x will equal 0 on 1, 5. Okay, justifying it, knowing what we have to look for, that it's continuous. We find the two y values, and then it's the y value I'm looking for in between them. Lots of words. All right, the math is not terrible, but the words are a lot to remember, okay? Let's also look at a couple of multiple choice questions, all right? How do they assess the intermediate value theorem with a multiple choice question? Because it typically will not say, hey, use the IVT, all right? We have to know that that's what they're referencing. Your hair looks really good for your picture. It looks really nice. Don't you love it when the curls work out just right? Yeah, Becca had one of those mornings today. She was like, my curls worked out just right. Did yours not, Carly?
They didn't curl up.
Okay, but you still look cute. Like, is this like a rose gold, the under?
It was like bright red.
Okay.
Over the silver.
Well, it looks really pretty, especially with the shirt you got on. Okay. All right, so let's take a look at this one. And when it's time for y'all to go, just go do your thing, okay? All right, so it says selected values of a continuous function are in the table. What's the fewest number of zeros of f in the interval from 20 to 30? Okay, so this is IVT, but it's kind of hidden, all right? First of all, the first thing I notice is it tells me it's continuous, okay? And it gives me an interval there, 20 to 30, all right? So we're looking at the y values in that table, all right? Zeros are where y is equal to 0, okay? So let's look at our intervals. If I look at the change in each y values, would it eventually go through 0? All right, well, let's look. From 2 to 1, would that go through 0? No. From 1 to -3? Yes, so there's 1. From -3 to -2? Nope. -2 to -3? -3 to 1? Yes, okay. So how many zeros do we have? I had 2 check marks, and it would be because f of x changes sign between 22 and 24 for x, 28 and 30, so it would be C. So that's how they'll test you on the IVT. It'll almost always be a chart. Okay, so a 0 of a function means that my y value is equal to 0, okay? So it told me that this table is a part of a continuous function. So all I really have to look at are these y values down here, and I'm going to check each set. Do I go through 0 between each set of y values? Between 2 and 1, I would not. But between 1 and -3, I would have to pass through 0. Okay, so that's why that would work. Okay? All right, try the next one. All right, same kind of thing. Right? It asks it a little differently. Okay, so let's take a look. It says values of the function k of x are given in the table. It tells me nothing about the function, okay? Which of the following is enough alone to guarantee that there is a number between 4 and 9 such that we'd get a y value of 4, okay? So first of all, in order for that to be true, that's IVT, all right? What's the one thing that has to always be there for IVT to work? Has to be continuous. So I can tell you right now 3 is not an option, all right, because it says nothing about continuity, all right? So if I'm continuous from 5 to 6, would my y value pass through 4? Yes, it would, okay? If I'm continuous from 4 to 5, would my y value pass through 4? Yep, so it's 1 and 2 only. Okay, so those are the kind of ways they're going to ask the question. All right, weird, but that's how they'll ask it, okay? The next one I want to do, next two I want to do actually are portions of free response questions. One calculator active and one that's not, okay? So this first one is calculator active, woo! Okay, and we'll do a lot with leaking water tanks. I don't know why that's such a big deal for calculus, but apparently that's a big deal places, okay? So if you're going to be an engineer, apparently leaky water tanks are an issue. All right, just so you know, okay? So it says the tank is leaking water. The amount of water left in the tank in the first hour is modeled by a continuous function, W of t, and it's a nasty one, okay? Where W is measured in gallons and T is measured in minutes between 0 and 60. Can the intermediate value theorem be applied to guarantee that there is a time in the first hour that the tank contains 100 gallons? Okay, so it specifically asks about the intermediate value theorem. Well, one thing has already been met, and that's continuity, so we're good right there. Okay, the first hour is an interval, so that would be 0 to 60. All right, 0 to 60. Now, we're going to need to know the value of W at 0 and W at 60. Have I showed you how to use this as a function in function form? I can't remember. All right, go to your y equals and let's put that equation in, okay? Anytime that we need to get several values for a complicated function, put it in y1, okay? So I'm going to actually put that nasty equation in y1. Let's see if I can get my app to work right today. It has been acting a fool. Okay. Okay.
Yeah.
See you, bye.
Where's it going? Where's it happening?
In the bowling alley.
Oh, okay.
Yep. All right, so I'm going to go to y equals. I'm going to clear out what's there. Okay. Let's see if I can read my own thing. All right, so we're going to get a fraction. Y equals a fraction. And so 500 over... Oh, is there a negative in front of that? Okay. And then 1 plus 40 e to, what is that? Negative what? What? 0.1 x, and then what are we going to add outside of there? 500. Okay, so once you get the equation in y1, if you go back to the home screen, so just get out of the graph, right, and we clear what's there. I thought I could shrink this, but I'm not sure how anymore. Okay, anyway, if you go to alpha trace, right, it will pull up the functions that we have in y equals. So alpha trace, I'm going to take y1. We're going to treat it just like function notation. That is w. I want w of 0. So in parentheses, I'm going to put 0. Your calculator knows that it's function notation, and it'll give you the answer. Okay. So it'll give it to you in function notation, which is nice. We can do it again. Since I've already done it once, second enter will pull back up that same expression. So second enter, and this time I can just change it to a 60. And hit enter. So it gives me my two values right there on the home screen. Okay. Which is nice. So it just works as a function manipulator, so it'll work like a function notation, which is good. You could use your table as well. Some of the functions, if we're going to have to get a lot of values, this might be easier, or if we have to evaluate a big complicated expression. So like if I want, y of 60 minus y of 0 over, like if I was going to do slope. That I can't do in the table, but I could do it here, alpha y equals, and then just type in all the stuff. All right, so, but yes, ask mode in the table works as well. All right, so now when we get over here, we know that W at 0 was 487.5 how many decimal places do we take? 3,805 gallons. And then the other one was 45.103. Water's leaking, so it makes sense that over time there's less water there. Okay. Are we going to eventually hit 100 gallons on the way out? Yes, we are. Okay. And so then we would write our sentence statement. So since we are given W of T is continuous on 0 to 60, and W of 0 equals 487.805, and W of 60 equals 45103, then IVT guarantees there was 100 gallons of water in the tank in the first hour. And that's what it's looking for. So notice that's all in terms of an application. So they want us to use the units. They want us to talk about it in the context, right, within that first hour. So using all that, okay? Then let's look at one more. It's actually from the 2007 free response questions. And number 3 is one part of that question. Now, every question has 4 parts. Back in the day, sometimes they would have 2, sometimes they'd have up to 6 parts. So now they've structured it where every free response question has 4 parts. That just makes it a little easier for them to grade. So this was the first year that happened. Okay. All right, last one. But it all kind of works the same, which is nice. Okay. So this is one. There's a lot of stuff on here that you don't know about yet, okay? But you're going to learn, all right? So it tells us that f and g are differentiable for all real numbers and that g is strictly increasing. The table above gives values of the functions and their first derivatives at selected values of x. The function h is defined as f of g of x minus 6. Okay? So, part A. Explain why there must be a value r when r is between 1 and 3 such that h at r equals negative 5. Okay? That is intermediate value theorem. It's hidden in the discussion, but it's there, all right? So let's see if we can figure all of that out, okay? Let's see if we can figure all that out. Because we want to know, is there a place where h of r is going to equal negative 5 between 1 and 3? Well, the first thing we have to know is that it's continuous. This is where this word shows up, okay? F and g are part of h, okay? H is defined as f of g of x. And because f and g are differentiable, then f and g are continuous. And again, that'll make more sense in about 2 weeks, right? So I need to find these values, h at 1 and h at 3. So we're going to have to use the table to help us do that, okay? I don't need these columns that have apostrophes, right? Those are derivative columns, but that's not what I'm talking about yet, okay? I'm just talking about function values. So we're going to do composition using a table, right? When we do composition, remember we start on the inside. So the first y value I need is g at 1. What is g at 1? It is 2. so now I need f at 2. So what's f at 2? 9 minus 6, and it gives me 3. Right? We're going to repeat that. We're going to start with g at 3. And what's g at 3? It is 4. And so then we're going to do f at 4, which is negative 1 minus 6, which is negative 7. Okay? So these are the two y values that I'm looking at. Is 5 going to fall between them? Or negative 5? Yep. Okay? Yep, it sure is. So this is where we would make our statement just like we've been doing before. Okay? Since f and g are continuous, are differentiable, they are continuous. And h of x equal to f of g of x minus 6 is also continuous. So now we've met, okay, we've met our conditions, okay? So we've met our conditions. Also, h at 1 is equal to 3, and h at 3 is equal to negative 7. All right, as such, IVT guarantees that h of r equals negative 5 on 1, 3. That's it. Okay. So this is all about understanding the qualifications, the conditions, and the conclusions to the IVT. It's all about the y values. Continuous, the y value falls between the y values of the two endpoints. That's it. All right. Your lesson practice is just that worksheet, okay? There are a couple of free response questions included there and some multiple choice just for you to practice those, okay? You do have a wrap-up. It's on Google Classroom, okay? Tomorrow we have a quiz on 14 and 15, all right? That's all your horizontal and vertical asymptote stuff, all right? Limits of infinity. Go ahead and do your wrap up on Google Classroom so you get that free point. I've posted the answer key to the worksheet as well, so you can check that as you work. Okay? But go back and look through that stuff on 114 and 115.